My name is Jörgen Städje. I've been a freelancer tech nerd for 32 years. Written about everything from mining to spacecraft, and in between that, nuclear power plants, jet engines, what have you. Before that, I was an electronic designer, and before that, I was a technical translator. Anyway, so I've been working now mostly with International Data Group, Netnod, and the Sunat. Where is it? Here. I have here my amateur radio transmitter, and this is kind of falling off now. It's interesting. Oh. It's important that the... Now. Okay, it's important that the microphone stays on. Alright, I have here my amateur radio transmitter. It outputs some 5 watts of power, and with this I can comfortably reach from here to somewhere south of Stockholm, let's say Skärholmen. No problems. I'd like to show you what NASA can do with 5 watts of power. What I can do with this is more or less microscopic. Space communications come in a lot of scales. From the very, very small scale to the absolutely huge. And this is the very small scale. Satellites in near-Earth orbit, such as the International Space Station, Earth resource satellites, and satellites with odd orbits, have problems communicating with Earth because they make gigabytes and gigabytes of data. And the only way to get it down to Earth is actually to wait until the satellite passes over a ground station. And there aren't that many ground stations, so the satellites will have to store their data for later dumping to Earth, which is not feasible, because you can't have very big hard disks in satellites. So NASA devised the tracking and data relay satellite. Geostationary satellites that will relay data from satellites in low Earth orbit or with strange orbits. And they can with 500 watts of power, they can transmit something like 300 megabits per second in the Ku and Ka bands. That's nice. So they kind of solve this downloading problem for satellite owners. But this is on a very, very small scale. I mean, here you can see the Earth. That's not very much. This is hardly visible in the next picture. So this is a slightly bigger picture. One day, when we're all living on the moon, there will be a laser link or a few laser links to the Earth, probably capable of a few gigabits per second. We will not be without internet, Skype, and Netflix. Of course not. The delay between Earth and Moon and back, in a telephone communication, for example, is 1 second. We can probably learn to live with that. With special training, we can accept such a delay in our telephone communications. Modern people are not going to be satisfied with "this is Tranquility Base, over. This is Houston, over." This is not going to happen. We want Skype or something. Once we have colonized the moon, we will continue. And in the next picture, the moon is hardly visible. This is the inner solar system. We have already traveled to part of the inner solar system. The Russians have been on Venus. We are now currently orbiting Mercury. There are 3 rovers on Mars, and there is someone going around Jupiter. are lots of communication satellites and stuff orbiting the planet. Communication will not be a problem. There's water, but no air. You can't have everything. Unfortunately, there's no magnetic field either, so the radiation from the sun's charged particles is about 1,000 times the normal radiation levels on Earth. You will have to live in a hole in the ground. Not a nasty, dirty, wet hole filled with the ends of worms and an oozy smell. Nor yet a dirty, dry, bare, sandy hole with nothing in it to sit on or to eat, but a hobbit hole, and that means comfort. The sun is a horrific radio transmitter. It's terawatts or more in every band you can think of. It will block out everything behind it. So when Mars is in the obscuration angle between the sun, behind the sun, we lose communications with Mars for 2 weeks. This is not so fun. But make no mistake, the day when we colonize Mars, the internet will be with us. The protocol is already in place. We get data from Mars every day, from several sources. Mars is a breeze, it's not a problem. Although the inner solar system is hardly visible on the next picture. So this is the whole solar system. And what's most impressive today are the Voyagers. The Voyager 1 and the Voyager 2. They are at the limit of human technology in space now. They have now left the solar system and is venturing out in interstellar space. They now live in a place called the heliopause, where the sun has no more power. The solar wind has ceased to blow and is replaced by the interstellar wind that blows between the stars. We know this because of scientific data about charged particles hitting the spacecraft, or rather, which has largely ceased to hit the spacecraft. Voyager has lived for 33 years in vacuum and minus 273 degrees Celsius, and it still works. And it communicates with us every day. The bit rate is not much, it's about 16 bits per second, but it works. And what's more, its quarter-inch tape recorder still works. Now that's reliability. Anyway, the solar system is not visible in the next picture. We talk about giga this and giga that every day. We can do the maths and we can write all the zeros, but we can't even begin to understand 1 billion of anything. 1 billion kilometers, 1 billion grains of sand, or billions and billions of stars. Our brain is not, made up of enough brain cells to accept or to understand 1 billion. We can't imagine it. Distances within the galaxy are in the range of 10 to 100,000 light years. 10,000 to 100,000 light years. It contains lots of objects making radio astronomical noise. There are astronomical masers with the power of 1,000 suns and the diameter of a solar system. Other galaxies also have black holes with a mass of more than 10 billion times that of the Sun and equal radiating power. But we can't really begin to fathom this. But LOFAR, the low frequency array, it can. It's all about shortwave listening in space. LOFAR is projected to be an antenna array the size of the Earth, and it will use very long-base technology. This will take a lot of coordination over the internet, it will take supercomputers, and it will take atomic clocks. We will, in principle, be able to hear Jupiter directly. Jupiter is a very strong shortwave transmitter. Jupiter has a very strong magnetic field, and when the charged particle from the Sun crashes into this magnetic field, it creates basically mega amps of currents, which acts as a radio transmitter, and we can listen to it here. But anyway, Our galaxy is just about visible in the next picture. So this is our galactic neighborhood. This is our nearest group of galaxies, all very audible to radio astronomers because they make noise from 1.5 gigahertz up to 40-50 gigahertz. Various ionized molecules emit noise at well-known frequencies such as water, hydroxyl, methane, ammonia, carbon monoxide, etc. All the building blocks of life. In this range of distances, we also have quasars, small objects radiating with the power of a whole galaxy. And so it goes on. But we are the problem. Will we ever be able to travel anywhere, really? Humans are a burden to technology. We are fragile, we grow old, we go crazy. If you really want to travel outside the solar system, could we? You might very well wait 3 hours for an email answer, but the question is if humans can survive 2 to 3 years in space without any stimulus, conversation, or new impressions. There were problems enough with the Russian Mars 500 simulation. To a human, space is black, silent, and empty. A lonesome around-the-world sailor will start seeing his mother-in-law in the masthead after 2 or 3 months of ocean nothingness.
Scary.
So, this is, I think, perhaps the first really interesting picture. There are spheres. Spheres of what we can take in form of communication. Like the Skype sphere ends somewhere at the moon. If we want a useful conversation with someone on Skype, we can't have more than maybe 1 or perhaps 2 seconds of delay in our conversation because it would be uncomfortable. So if we go further out to Mars, it's Facebook time. You couldn't converse with someone with 13 minutes of delay in your conversation. It's impossible. So it's Facebook time. And you can be sure that Facebook will be with us on Mars for better or for worse. If we go further, if we can survive it, I mean, going to Mars, that's half a year. We will be bored, extremely bored, but I think we can probably take it. Let's go to Jupiter. That takes 1.5 years. People will go crazy. Without stimulus for 1.5 years, you could take the whole of Netflix with you, but you would probably go crazy from that instead. So when you reach this Jupiter, Saturn somewhere, email is the only possible way of communication. If you live that long. Let's go to Pluto. An Earth spaceship recently visited Pluto. It took 9 years to get there. We will probably be dead before we get there, or we will have to sleep. Cryostasis, but that hasn't been invented yet. NASA is working on it, but it hasn't been invented yet. Problem with freezing living human beings is that all the fluid in your cells will expand. It will freeze into ice crystals, and it will expand, and it will crack the cells open, and then be dead. So, I mean, that's a problem, really. And, well, it'll be difficult to go beyond Pluto's orbit. So, what are we? Now I'm getting philosophical here. What are we in space? Or nothing really. This illustration is Voyager's final panorama of the solar system, which I just put on top of the Milky Way. This is what it would look like from Voyager's vantage point at the moment. You can see the sun, perhaps, if you're really good. Does this one has a pointing something? Yes, it has. Oh. The sun is here, okay, nice. The pale blue dot of Earth is there. Maybe you can see it, maybe not. What are we? We're nothing. Can you see the internet there? No. Can't. There's a lot of SETI going on, search for extraterrestrial intelligence. It means us listening to others' space communications. Have we heard anything? No. How long has it's been going on since 1999 in several places, several frequency bands, in microwaves, in light, in whatever you can think of. Have we heard anything intelligent? No, nothing. We have bounced radar waves of Mercury, very interesting. I talked to the guy who did it, very intelligent guy. But all the SETI organizations of Earth have heard absolutely nothing from any extraterrestrials. I have no doubt that there are extraterrestrials, but they're not talking to. We can infer that there are extrasolar planets, and the new 50-meter telescope in Chile will be able to see them directly. But it seems like they are empty. What are we doing wrong? Are we using the wrong frequencies? Should we be using light? I don't know. No one knows, unfortunately. Okay, what can we do? This is NASA's Deep Space Network. It's their chart. If you plan on making a spaceship, building one, and you want to send it off somewhere in the solar system, what sort of communication rates can you expect from NASA? NASA has 3 big antenna farms at 120 degrees around the Earth, and they are equipped with 70-meter parabolic antennas, big ones, 20 kilowatt transmitters, and because they are at 120 degrees around the Earth, they will always be able to see all points of space at all time. So you could theoretically have unbroken communications 24 hours a day. Okay, so what can you do? Well, let's say, or what can they do? Well, let's say you want to go to Pluto. It's a nice place, it's cold, but it's a nice place. Pluto is well, considering the 70-meter antenna, 20 kilowatts, they can give you somewhere around 1 kilobit per second to Pluto. And that happened. The New Horizons spacecraft communicates in 1 kilobit per second. It means that the pictures it took during the 15-minute meeting with Pluto will take 2 years to beam back to Earth. You might argue now that, well, the New Horizons uses 10 watts of power. It's not the same, the link is not symmetric. Well, it is because the receivers on Earth are much better than the ones in the New Horizons spacecraft, and the antenna on Earth is much bigger than the one on the spacecraft, so it's about equal. And I'm returning here to the Voyagers, of course. They are now at 110 and 134 astronomical units from Earth, and they still communicate with us every day. They have a transmitting power of 20 watts at the moment. That's a good, I mean, that's quite a feat over 19 billion kilometers. Right, so let's see what we can do. This is Voyagers. The Voyagers gave us the first real picture of the outer planets. In 1979, we got the first real glimpse of the solar system. We knew that Jupiter looked something like this from telescopic images, but finally little Voyager was there up close. It also came close to Saturn, Uranus and Neptune, but missed Pluto at the time. All the time communicating. The Voyagers left Earth in 1977 with only a 6502 processor to run them. As the craft got farther and farther away from Earth, new software and new compression algorithms had to be uploaded as the bandwidth decreased. Download of a picture could take days or weeks. The crafts have triple redundant computer systems, each with 32 kilowords of core memory. As the voyage went on, new software had to be uploaded. The whole trip around Neptune and the encounter with the moon Triton took only 2,200 machine words of memory, something like 5 kilobytes. NASA has people who knows how to program. Right. That was a long time ago. And you see, the picture is 800 times 800 pixels, not very much. The next one is much bigger. Okay, we have 3 rovers on Mars. The Spirit, the Opportunity and the Curiosity. This panorama took several days to make and has been stitched and color compensated on Earth. You see, at the bottom here, you see the Mars rover itself, which has been warped because of the panoramic method of putting the picture together. You also see that there is actually a bit of frost on one of the solar panels. It's cold up there. It's minus 100 degrees in the night and about 0 degrees in the day. Well, they can do it. I mean, jet propulsion laboratory guys are good. There was some remote troubleshooting needed. One curious thing happened when Spirit landed in 2004. It has been called the Sol 18 problem. A routine for testing the robotic arm stored too much data in RAM. When this happens, Spirit will restart and restart all the so-called critical programs. It did and restarted the testing routine. They were testing the robotic arm, seeing how many amps the motors took, etc. And the testing routine was restarted, and it overran RAM again and was restarted again. And this went on for several days, several Mars days and nights, until the batteries were almost exhausted. When that happened, the system was rebooted in diagnostic mode, and JPL could finally get their foot in the door and dump memory over 55 million kilometers. The problem was fixed, of course. This is NASA doing things. But you see the size. Now we have 10,000 pixels in the picture. The resolution is increasing all the time. Okay, I'm very impressed with Cassini, now orbiting Saturn. This is a 4,000 times 3,000 pixel stitched panorama of Saturn. The pictures were sent down over a 14.2 kilobits per second link with only 20 watts of power from 1.3 billion kilometers distance. It's getting better and better. Okay. Recently, our friend New Horizons zipped past Pluto in 10 minutes, and then it turned around and turned the cameras towards Pluto as it was leaving. All in all, 20 minutes. The link from Pluto was 1 kilobit per second, and the spaceship had 12 watts of transmitting power from 4.8 billion kilometers. Most of the images of the Pluto encounter took 20 minutes to make in all, and will take 2 years to deliver to Earth. Again, remember, this picture has traveled 4.8 billion kilometers to reach. Okay, radio galaxies. A radio galaxy is something very far away in our galactic neighborhood. that will transmit noise to us at exawatts of power. It will reach all over the universe. This is how a galaxy looks when scanned with a radio telescope. The bright spot in the middle is a maser, a microwave amplification by stimulated emission of radiation. It's like a very, very large laser, but it operates in microwaves. Okay, this is how a maser works. Space is full of gases. Space is not empty. Space is full of gases. And near solar systems, these gases are denser. Some of them are the building blocks of life, such as water, hydroxyl, methane, ammonia, carbon monoxide, etc. When the cloud of such gases is ionized by the ultraviolet light of a nearby star, they emit and work like a maser, with stimulated emission of radiation. In this case, for example, in 1667 megahertz, the frequency of water molecules. This is a machine the size of a solar system. Well, this little point sticking out there. So there's a lot of communication to listen to if you really want. There's lots of it. But then there's space only communication. We're having a problem with our central star, because when the sun is angry, it will throw enormous amount of radiation on us, and it will disturb our communications. Sometimes our sun makes space communication difficult. It even threatens communications here on Earth. If we're unlucky, a bit of a mass ejection will hit Earth and fry our satellites and computer systems. This is a very nice picture. It's made by a sun-orbiting satellite. I don't remember the name of it. But anyway, this tail shooting out from the sun contains 10 to the power of 13 joules. And if it would hit Earth, we would see it as a very nice aurora, but our computers might not survive. But we know the dangers now. With modern technology, we can more or less counter the dangers. This picture is secret. Ooh, don't tell anyone you saw this picture. I took it in an EMI safe computer room somewhere deep in Stockholm. This room is made of steel, all soldered together, and and all the cabling coming in, it comes in through wave traps. Fibers going in and out go through long tubes called traps. So it doesn't matter if the sun erupts or if a nuclear charge goes off in space or something, it will not hurt this interconnection point. And the telephone communications in Sweden will stay up, which is the main point. Since the first Carrington event, and the first Carrington event was, there was a British scientist called Robert Carrington, who happened to look at a compass when the sun had a large eruption in 1889, something. And he saw that the compass changed, oddly. Usually the Earth's magnetic field will not turn around, it doesn't happen. But for this event, the Earth's magnetic field changed. And he concluded that this had something to do with the sun. It was the first time someone had made this connection, that the sun could change the Earth's magnetic field. And then he started thinking, how did this happen? And it's obvious that a lot of energy is traveling towards Earth when there's a solar storm going. But we just can't allow a solar storm to kill our telecommunications and the internet. Earlier, the railway signaling systems had problems during a geomagnetic storm. As voltage developed along railway tracks, several volts per kilometer, This disturbed the main train protection system, which is based on 6 volts only. We now have regulations in place that to largely eliminate this. Trains can continue running during large auroras. Also, bank burglar alarms would regularly go off during solar storms, but this has also been eliminated. The space weather is bad. There's nothing we can do to help satellites in space. Modern satellites are, however, built to withstand this to some degrees, and they will shut down and restart after a solar coronal mass ejection. Just to make sure we are ready, we have solar observatories in orbit that will give a few days of warning. And these solar observatories does actually survive. But they take this unfortunate Japanese Mars craft, the Nozomi. Nozomi means hope. It was hit by a solar storm in 2002, which killed some of its functions, and it never reached Mars. And also, we're back to humans being a burden on the system. Humans would, for example, not be able to exist near Jupiter, as it has the strongest magnetic field of all planets. The field pulls in so many charged particles from the solar wind that we wouldn't survive even a minute in the field. Spaceships can be radiation hardened to withstand this, if we work hard on it. So, but there are now, this is unfortunately my last slide here. I have some recommendations for those who would like to continue studying the interesting phenomena of space weather. I'm myself very fascinated with space weather. You could watch the film Contact with the manuscript written by Carl Sagan. You know, this astronomer who made the phrase billions and billions of stars famous. He wrote this film manuscript. And some of the radio astronomy are almost real, most of the time, but then it goes crazy. I have also written a lot of articles about space weather, how it is investigated, and how it affects us on Earth. Basically, we run around space with a big ammeter and measure the currents that flow from the sun and outward. Charged particles represent an electric current, and we're talking about teraamps flowing out from the sun. And when a teraamp hit the Earth, there's going to be some results. Some of the solar wind falls down on Earth and other planets. On some planets, it flushes their atmospheres away, such as on Venus and Mars. I would also like to put your attention to the Institutionen för rymdfysik, the Institution of Space Physics in Uppsala. They're very good at producing instruments like space ammeters and space voltmeters and these kinds of things. And they are all over the solar system today. Swedes are very good at building these sorts of instruments that travel all over the solar system. Well, I forgot to make the compulsory thank you for listening slide. You will have to imagine it. You can also download my PDF file called Teknikaliteter, as we heard before, from the Netnod homepage. Click on the Netnod Spring Meeting and then find the bonus download and have a good time. This file is a conglomerate of some of my articles from the past years. It has 210 pages of pure nerdy technology for those of you who wants to learn Swedish the hard way. And remember, not all great technology comes from California. If you feel I could write a techie article for your organization, don't hesitate to contact me. Well, questions, please.
Fascinating stuff. Any questions? Can I ask Vanessa, where do lolcats get into all this?
Sorry?
Where do lolcats, kittens on the internet, fit into all this?
I don't get it. One more time.
Kittens on the internet,
Kittens.
funny videos of
Yes,
kittens.
kittens, yes.
Where does that fit into?
They will be everywhere.
They're very good. That's very encouraging. That's what I wanted to hear.
I don't know if you're aware of this, but it seems like now cat traffic on the internet is now stronger than porn traffic. This is amazing. Well, it's good, but it's amazing.
All right, if I can bring us back down to earth. That was the worst pun I could come up with. Thank you. I did a Google and looked up some of your stuff online. You were a ham radio operator, but you said you gave up. And I'm intrigued at that. Because I'm a ham radio operator.
Yes.
And I think I may sort of make you feel pretty good about this, because I still build stuff.
Uh-huh.
I still use a soldering iron or a soldering iron, depending on where you come from. And occasionally either burn myself or give myself an electrical, shock.
Yes.
And have done since I was a kid. So I'm sort of intrigued at all this stuff that's out there in space is built by, as you said, really smart people. It pushes the envelope. I mean, watching Voyager, both Voyagers tweet, by the way. It's not really them that tweets, but it tells you where they are and what they're doing. But are we still building the type of technology that we need to do this? I mean, everything you've talked about, these New Horizon that went to Pluto, and are we building even bigger and better spacecraft with better technology all the time, or is that little bit of, if I may say, disillusionment I saw on the web, on your ham radio web page? But is this a positive mindset or a negative mindset here?
Well, NASA has a roadmap. NASA is a great educator, and they have some sort of responsibility for teaching the public about space. It's part of their roadmap, and they have what they call they have small projects and big projects, and there is a roadmap of a big project every 10 years or something. And, we could talk about the James Webb Telescope, for example. Hubble is getting old. Hubble is about to deorbit and crash back to Earth. There's nothing more we can do about Hubble now. So, if we take the James Webb Space Telescope, it's a really, really big thing, which would be placed in one of the Lagrange points, 1.5 million kilometers from Earth. Unlike Hubble saw the space, I see still, space in visible light and some shortwave infrared. The James Webb Telescope will study space in long-wave infrared, to be able to peer through dust and see further back in time. About only 800 million years from the Big Bang will now be possible to see. Hubble could not do that. The technology behind the James Webb Telescope is fantastic. Just putting a helium refrigerator, everything up there to keep receivers and cameras cooled down to minus 272 degrees is really an achievement. They call it flagship projects. NASA has flagship projects. There's a new Mars lander about to go. It's ESA, it's European Space Agency's lander. A few Swedish companies has taken part of this new lander, which I don't remember the name of. It's on its way there. And I might mention a project on the KTH, the Royal Institute of Technology in Stockholm, where I have taken part, it's the program working on Venus, where the RTI actually wants to put a craft, or several. I have suggested to them that they make several crafts and land them on Venus. Unlike NASA, who wants to send refrigerators to Venus to house the electronics, the Working on Venus project has developed high-temperature electronics. They're working while they're glowing orange. Works very nice. I have seen logic gates, I have seen operational amplifiers and oscillators glowing red and still working perfectly. They will be able to work in the Venus atmosphere at 450 degrees. They're in the phase of developing CCD arrays for cameras, CPUs, memory, communication equipment, of course. We have this idea that landing on Venus may not be so hard, because the Venus atmosphere is 90 times the pressure of Earth's atmosphere. It's like walking around in water. The Russian Venera craft didn't use a parachute. They glided down through the atmosphere using their parabolic antenna reflector as the only means of braking, and they hit the Venus surface with only 8 meters per second. So landing on Venus may not be such a hard thing. Surviving on Venus is much worse. The idea is that the KTH project will survive at least one Mars day, which is 270 days. I believe 270 Earth days. My suggestion is that we make about 5 or 6 of these craft and put them on the equator, land them on volcanoes, land them on the polar regions to be able to get a bigger perspective, and 1 or 2 of them could fail, it wouldn't matter. So yes, I think we're still building fantastic technology. Yes.
Okay, robots versus humans. Seems like you're betting on robots.
I don't know anything about your robots. I don't know. All these spacecraft are robotic. The Curiosity lander landed by itself. You can't command something when there's a 13-minute delay between your command and the answer. You cannot go in and you use a joystick and play around with this Venus lander or something. It has to land by itself. It must be a robot. It must have radars. It must be able to understand an atmosphere. Yes, there must be robots.
One more question.
Well, this is more a comment than a question. Actually, there is this new thing that it's a couple of years that they are testing and actually using at NASA and on some other commercial satellite operators. And it's basically using laser instead of RF, instead of radio frequency. And there has been actually a couple of successful tests. I think there was like a 1 point some terabits per second or something connectivity. There was a from moon to from orbit of moon to the land here in Earth. I think there was a couple of hundred megabits. I couldn't find the numbers, but it's called laser communication relay demonstration, LCRD. That's actually not bad to look up to because it doesn't have all the limitations of the radio frequency, and it consumes much less power and it's much faster.
Well, there is a problem with Earth, we have weather. Microwaves don't care very much about weather. But terabit speeds are indeed possible over lasers from well, moon orbit to Earth orbit, because there is nothing in between, so you can have any speed. The problem occurs when you want to go down to Earth. Let's hope for a space elevator that will, you know, it will be a solid, some sort of tower built from the Earth up to geostationary orbit, where we can actually, you know, pull a fiber or something all the way up to geostationary orbit. I read about a Japanese company who is actually planning to build a space elevator. It was a science fiction idea many years ago, but it may actually be coming true. And once you're in geostationary orbit, it's no problem. You can beam lasers everywhere. Probably lasers is the next best thing if you want to go to Mars. Because well, humans are communicative. We want to talk. We want to exchange images of cats with each other. We kind of blah, blah, blah all the time. We want bandwidth. And I believe lasers is the best thing. You can probably project a laser halfway through the solar system and hit something. I don't think that's a problem.
Okay, one last question. This is clearly generating some fascinating thoughts in people's heads. Go for it.
Actually, it is not a question. It's more like I want to share my thought when I'm hearing your talk. And I really, you know, when you started, I was very fascinated. You know, thank you very much for the talk. And I was thinking, oh, Facebook is going to be in Mars. Great. NTD is always, you know, our motto is like we are always built to where our customer is. You know, so I may be the first spinning coordinator in Mars. And I'm thinking, dreaming, okay, where is Netnod or iAccess is going to be in Mars? So, and then later on, you know, going on, and then here comes Martin. And then your answer to Martin's question is like, oh, got to be a robot. I said, you know, not even a woman can go to Mars. I have to be a robot. So I am, you know, like from a yo-yo down to this point. And there's many thoughts, but you know, time's up for the lunch. So thank you very much for the talk.
Well, you can just, you know, join up with me later and we can continue talking. Let's have a, you know, Mars gathering later this evening, no problems. I can speak endlessly about this. I have written some 1,100 technical articles